So I guess this is my plan. I think as slow as I'm going through chapter 3, when we get through with 3, we'll probably have a test on chapter 3 only. And then we'll get probably by the end of the year, we'll get through 4 and maybe into 5. I don't know. Because it's getting a lot tougher. I notice from everybody's tests. So anyway, number 10. I don't believe we did that one, did we? Now 10 is, I think, pretty difficult one to do. So it says a right regular pyramid has a height of 10 inches and a base that is a regular octagon with sides of length 3. Find the surface area of the pyramid rounding to the nearest whole number. If I can draw this it's 8-sided figure. So I'm gonna try to draw I'm not going to get it in good perspective. I didn't. And I didn't draw that low enough. I'm going to go to a new one. I got to get this low enough where we're going to be able to see it. So it don't look too hot. I'm going to go with it. Okay. I cut this thing up. Okay, then down in the middle here, that's in the center of the base. And then, let's see, that's supposed to be the height inside there. And then, so it's an 8-sided figure. This height right there is 10. In inches. And then each one of these is 3 inches. And they want to know the surface area. Okay, so the surface area is going to be the area of the base plus the area of the sides. Now the area of the base is, look back on, the whole formula is on page 149, but I'm looking for the area of the base. And the area of the base is each one of those triangle. So what we got to know for the area of the base we have to know this distance right here. And we don't have, all we have is that green height and the 3. So in order to figure out the length of that purple line, and what we're going to have to do that trapezoid right there, we're going to have to break this down into 2 pieces. We're going to have to figure out how far it is from here to here, and then from here to here. Well, this distance, which isn't in good perspective, is pretty easy. This is 3 inches, right? So this distance right here is 3 over 2, right? 3/2. It's half the distance. But we have to figure out this distance right here. And that trapezoid, what we got to do is we're going to have to figure out what this angle is. And then we can figure out the height of that trapezoid coming up there. So to figure out that, we have to find the vertex angle of that octagon. So the vertex angle of the octagon is going to be, the general formula is n minus 2 times 180 over n. So it's 8 minus 2 times 180 over 8. So that's 6 times 180 over 8. And now what I'm going to do is I'm going to do some canceling. This is 3. This is 4. And then 4 goes into 18. 45, right? So that's 135 degrees, is that right? Each one of those vertex angles. So I'm going to have this so scarred up. We're not going to. So this angle right here and this angle right here in this trapezoid measure 270. So these 2 angles are going to be the interior angles of the trapezoid is going to be the interior angles of the trapezoid. Angles of trapezoid is going to be 4 minus 2 times 180. So that's 2 times 180, which is 360 degrees. Then there's 2 angles that are 135, because this angle is 135, this angle is 135. So then we have to subtract 270 from it. We get 90. That means the sum of this angle and this angle are 90 degrees, so that makes this angle 45 degrees. So I'm trying to figure out what this is right here. Well, if that's 45-degree angle, then this side right here is 1 over the square root of 2 times this 3. Over the square root of 2. So that whole length, that purple length, that whole purple length, this length right here is 3/2 plus 3 over the square root of 2. Now, to find the area of the base, it's 1/2 of the base times the height. Base times height. And then there are 8 of those. There are 8 of those triangles going around. So that's why it's perimeter. Because if you take 8 times the base, that's the perimeter. Because they'll say, the formula, if you look it up, will say 1/2 of the perimeter times the height. Well, this perimeter is, for this one, is 8 times that 3, which is the base. So what we have is 1/2 8 times 3 times this 3/2 plus 3 over the square root of 2. That's the area of the base. Now the area of those sides, what we have to do to get that is I don't know which color I want to use. I don't have much left. What we got to do is we got to find down this side like this, where this is perpendicular. Well, there's a right triangle. There's that green thing, and then this 3 square root of 2, 3 over 2 plus 3 over the square root of 2 is 2 sides of it. So we can find that purple length, this length right here, by doing the square root of that middle height is 10, right? 10 squared plus 3/2 plus 3 over the square root of 2, that quantity squared. So the area of the pyramid, the sides, the area of the sides, is there's 8 of those triangles, and each of those triangles is 1/2 of the base, which is 3, times the height, which is this thing here, square root of 10 squared plus the quantity 3 over 2 plus 3 over the square root of 2, that quantity squared. So if you put that whole thing together, the surface area is this one right here added to this one right here. It's 1/2 8 times 3 times 3 halves plus 3 over the square root of 2 plus 8 times 1/2 3. Now, if you look at these two, that really is, that constitutes the perimeter. 8 times 3 times the square root of 10 squared plus 3 halves plus 3 over the square root of 2 quantity squared. Okay, so if I do this, it's 8 times 1/2 is 0.5, that'll be accurate, times 3 times bracket 3 divided by 2 plus 3 divided by second square root of 2, close the bracket, plus 8 times 0.5 times 3 times square root 10 squared plus bracket 3 divided by 2, yeah, I guess I got that back in there, plus 3 divided by square root of 2. Bracket squared okay, let's see, I got 3 halves and then 10 squared and then 3.5 and 8. Did I get everything in there right? Did you? The first one said 8 times 0.5 times 3 times. If I got it in there right, that's the answer. 171. Does that make sense? Good. Okay. It says find the surface area of a pyramid if its base is 10 by 18 rectangle. Assume the apex is centered over the base. This one might be able to print on. that right in perspective. They have this, that's the center of that 10 by 18. That's the perpendicular height. So this right here is 12. This is 10. And this is 18. It isn't quite in perspective. What we actually have to do, we gotta find this, gotta find this thing right here. And then we gotta find this one. This is 90. And the way we're going to do it is we're going to form a right triangle here. And we'll find because this is a right angle there, and then we're going to find a right triangle here because this angle right here is a right triangle. Right angle, so it's two right triangles, and the purple line is the hypotenuse, and the green line, this purple line is the hypotenuse, and this green line is the hypotenuse. And this distance right here is half of 18, which is 9. And then this distance right here is half of 10, which is 5. And we got to calculate this. We got to calculate this. And we have 12 inches. And so what we're going to do is we're going to be calculating the size of the one side triangle, and then the other two surfaces, because there's two surfaces that are 10-inch bases and two surfaces that have 18-inch bases. And what we need to know is that this purple line for the 18-inch base, we need to know this green line for the 10-inch base. And that purple line is going to be, it's going to be the square root of 5 squared plus 12 squared. That's what this one is. And this one is the square root of 9 squared plus 12 squared. So this is going to be the square root of 25 plus 144 is the square root of, what is that, 169? And that's actually 13, correct? So that's 13. And this one is square root of 81 plus 144. And that's the square root of, what is that? 225. Is that right? That's right, and that's 15. Correct? So the surface area is going to be the area that 18 by 10 base. It's the bottom of the pyramid. This one is the bottom. Then we have two sides that are, if we look at the one that has 10-inch side, that's this side here. It's 1/2 of the base 10 times the height, and that height we said was 15. And then we have two sides, the area of which is 1/2, and the base is 18, and the height is this 13. So this is 18 times 10. The 2's go out, so it's 10 times 15 plus 18 times 13. Plus 150 plus, how can we figure that? That's 180 and 3 times 18, 8, 16, 24, 54. Is that 234? Okay. So then that's 4, 16, 564 inches squared. Says find the surface area of the following cans rounding to the nearest whole number. Well, the surface area of a can is that formula. It's going to be on page 149. Surface area of a right circular cylinder. It's 2 times the area of the base, circumference times the height. And we're back to it. I don't have a dashed lines. And this thing is going to be, what is it? The first one is the radius is if you go from the center out, that this is the radius, and then so this is the radius, and then this is the height. And the surface area is the area of the base 2 times area plus the circumference times the height. So A, surface area, and the area of the base is pi r squared, right? And the circumference, if you know radius, it's the diameter times pi, so that's 2 times the radius times pi times h. Now they have a different way of laying the formula out, but for when the radius is 5.3, that height, it says it's 17 point. So just try to do kind of logic about the thing. That's the way it's going to go. Okay. Remember what that is. Now they'll have a different way to formulate that thing out, but the way I'm doing it, it's logical to me, and so this thing's going to be it's 2 times second pi times 5.3 squared. So that's the two bases. And then it's going to be the circumference. So that's 2 times 5.3 is the circumference. 5.3, 2 times 5.3 times pi. That's the circumference. And then times that height is 17 point, what was it? 17.7. So let's do that. And then that B part on 14 is going to be basically the same thing. Way to calculate it as the A. Okay. It says the surface area of right circular cylinder is 1,200 centimeters squared. The height of the cylinder is twice its diameter by the dimensions of the cylinder. So, all right, circular cylinder. they're saying this height, says the height of the cylinder is twice its diameter. So this is the radius. This height equals 2 times the diameter, which is 2 times 2 times the radius, right? 4 times the radius. And the reason I'm going radius is because, you know, the formulation for this thing is all in terms of R. So that 1200, which is the surface area, is 2 times pi r squared. That would be the ends plus it's the circumference. So that's pi times the diameter times 2r times the height. So what we can do, we can substitute our 1200 in there. 2 pi r squared plus pi times 2r, and then for the height put in 4r. So we have just one variable. Plus, this is 8 pi r squared, right? So we can factor out 2 pi out of there, and we have r squared plus, what is that, 4? Is that right? And this is 5r squared. I guess I could have just gotten 10 pi r squared. I wasn't thinking very good. Is 1200. So then r squared equals 1200 over 10 pi, which is 120 pi. And then r is going to be the square root. It's positive square root 120 pi. And what am I supposed to be doing? Find the dimensions, right? Of the cylinder. So I got to get this thing. What was that? That was 120 over 5, wasn't it? Wasn't that? 120 divided by pi. What's the square root of that? So now I have to go, can I do that? Oh, I should have gone square root and then pushed that. Then what what I should have done is second square root and gone up and got that. And then enter again. 6.18. So this is 6.18. So by substituting in, the diameter is 2r and the height is 4r. So the diameter is going to be 2 times 6.18 and the height is 4 times. If I multiplied right, 32. Did I multiply right? Get it? Okay. It says find the surface area of each right circular cone to the nearest whole number. So they're giving us this diameter, right, which is 48 inches. And then this distance right here is 40. Okay. There's the formula back there. The surface area of a right circular cone. It's on 150. Now those handout sheets that I gave you, they got formulas, so you're going to have to kind of know where the formulas are that you're going to have to use. And so the surface area is the area of the base plus 1/2 the circumference, and this is L. So the area of the base is going to be pi r squared, right? 1/2. The circumference is going to be pi times the diameter times L. Pi. The radius is 24, right? Plus 1/2 pi 48 times 40. So that should give it to you. On that B part, this is the A part. That B part, and I'm just going to use this existing because we're going to run out of time. What they're giving you there because they're giving you this is 35 inches. Then they're giving you this is 50. Well, what you got to do is you got to find that length right there. That's that L. And what you do is it's going to be the radius here is going to be 7.5, and then you got 35, so that L is going to be the square root of 35 squared plus 7.5 squared. So just, that's how you're going to be able to figure that one out.